My name is Victoria Fabian. I'm Dr. Thompson's PhD student in environmental science, and I'm one of the supervisors of the internship this summer, along with Ms. Christina Reeder. We're very excited. This is a group of very talented and hardworking high school students about to be college students. We had a lot of help this summer. Thank the City of Dallas. We thank you for funding this project, allowing us to do this research. We found some really exciting results. Clinton Onyemaichi is one of our supervisors as well. He helped a lot, gave a lot of guidance to our high school students for their presentation. Shane Heffley did a lot of work with the technology and also helping us analyze the results, and then we were all under the guidance of Dr. Thompson. So thank you all for being here, and I'm going to let them take it away.
All right. Okay, good morning, everyone. We would like to thank everyone for coming out today. We'd especially like to thank the City of Dallas for having the intuition to fund a program such as EEI and for giving us this wonderful opportunity. My name is Omar Chavez. I'm a recent graduate of W.T. White High School, and I'll be attending Texas A&M University in the fall to study renewable natural resources.
Hi, my name is Rahel Tasfi. I recently graduated from Richland Collegiate High School. I'll be attending UTD in the fall, and my major is international business with an interest in environmental sustainability.
Hello everyone, my name is Neil Stanley Ramirez. I just graduated from the Science Engineering Magnet, the Ivana Yotami Center. This fall I'll be attending The Ohio State University and majoring in mechanical engineering with the status of a green engineering scholar.
Good morning. My name is David Pacina, and I recently graduated Trinidad Garza, ECHS at Mountain View. And this fall, I'm going to UNT for mechanical energy engineering with an emphasis in sustainability.
Good morning, my name is Stephanie Almendares. I graduated from Justin F. Kimball High School. I'll be studying environmental design at Texas A&M University. So I'd like to welcome you everyone once again to the 2013 City of Dallas Environmental Education Initiative study. So the City of Dallas Environmental Education Initiative encourages water conservation and recycling. Not only is it about going into the classrooms and providing lessons over water conservation and recycling, but about infiltrating the minds of the youth and of the community about how important it is to conserve what little water we have and how recycling can make a difference. Some of the methods EEI uses to reach the community and the students are by hands-on in-class lessons for the students in K through 5, museum exhibit modules for middle school students, and for high schoolers such as us, there's the summer research internship, professional developments for the teachers, and outreach events for the community. Before we could conduct research, we had to learn about EEI and how to use the tools that would help us in our research. One of the main components of our training was GIS, which David will talk about.
Okay. So what GIS is an acronym for Geographical Information System, and this was taught to us by Victoria Fabian, which I'd like to thank. And what it is, though, it's a computer program, and we use ArcMap, where you can put in data quantitatively in numbers, and you get out these qualitative visual representations of that data, and aka maps. And that's where we can put legends and just show trends, relationships, and patterns. As you can see, this was made by one of our interns, and this is the City of Dallas ZCTA. We'll go into ZCTAs later, and as you can see, those are different shades of green, which represent the council districts.
Here is a picture of us at the Elmford Water Purification Plant, which y'all set up the tour for, and we're very grateful for that. Here we learned basically how water is filtrated through physical and chemical systems. So all this water is coming in from the Trinity River, and then it's going out into our homes, which we wash and clean and stuff like that.
And then another component of our intern training was visiting the Dallas Southside Wastewater Treatment Plant. So at Elmford we got to learn about where our water comes from, and here we got to learn about where our water goes. So here we have another picture of us standing over some of the water tanks, and you can tell we all have masks on. It smelled really bad, and actually got made fun of because apparently the whole day I had my mask on backwards, and they looked at pictures, so people give me a lot of stuff for that. But anyways, there we got to really look at the way that the urban water cycle looks. You know, as I actually learned about it back in my senior year in environmental science, like we just read about it. But now with these two plants, I really got to see exactly how those processes work in person, which was really cool.
So it was hot and stinky out there then?
Yes, very.
Yeah.
Had a good combination. We were also given a condensed staff development in which we experienced firsthand the kinds of lessons that the students go through when EEI teachers come into their school.
This is an overview of what the presentation will entail. We'll start with a few key terms, followed by 2012's research, along with the research we conducted this year, and we'll be concluding the presentation with the results. DISD stands for Dallas Independent School District. EEI and GIS have been previously defined. Zip code is what the Postal Service uses for mail delivery, and ZCTA is what the census uses to collect data. And on the next slide, there's a map of zip code, what the zip code is, and ZCTA. In the blue outline are the ZCTA boundaries, and in the tan outline are the zip code boundaries. And in the zoom in of our research area, you can see that the ZCTA and the zip code boundaries are similar, so they're not different at all, really. Now, Omar will talk about last year's research.
Okay, so as we all know, EEI has been educating children on water conservation for many years now. And at the end of last school year, they noticed two areas that were served rather differently. In one area, there was about 4,000 students served versus another, where there were only about 200 served. It was wondered if this difference in the amount of children served would cause a difference in the amount of water used by these two areas, and that's what was set to research last summer. Here are 2012 research areas. Research Area 1 is shown here in the blue, and consists of ZCTA 75236, 75233, 75237, and 75224. That research area is where there were 186 students served. Research Area 2, shown here in the green, consists of ZCTAs 75211, 75212, 75208, and 75203. In that research area, there were 4,190 students served. On this map, we have our research areas with the schools highlighted. Our research areas are shown here outlined in the blue and the green. Research Area 1 in the blue, and Research Area 2 in the green. Our schools are highlighted by these red pins. And the shaded color, the different shades of color surrounding the red pins symbolize that school's respective attendance zones. So that's where that school exposes to anybody from. On this map, we have added our water data. Each of these green dots in area 2 and blue dots in area 1 symbolize a single family unit from which we were able to draw water usage data from. So we were able to see how many gallons per month that home, how many gallons of water per month that home actually used. What we discovered from last year's research was that yes, education does seem to play a role in lowering water usage. And in our two areas specifically, Area 2, where there were 4,190 students served, they ended up using 89 gallons per home per month less than did Area 1, where only 186 students were served, which is very neat stuff to find out. So last year, our intervention occurred over multiple ZCTAs, and we did notice a measurable difference in water usage. Then we thought, what if we were to target 4 schools within one ZCTA and target them with water conservation education, by which I mean going to each school in the ZCTA and teaching all students in that school about water conservation. If we did that, would we see the same kind of results that we saw in last year's study? And that is what EEI teachers went out to do during the school year, and it was up to us as interns to see if it worked or not. And now Mr. David Pacino will explain to you the variables involved in our research.
Okay. So in order to better explain the variables, I just want to, show you this map of the 2012 summary, which Omar went over. In order for a study to have its results that it has and be reliable in their conclusion and their results, there needs to be two variables. One is the independent variable, and that's the variable that changes, and the other is a dependent variable, and that's the variable that's being measured. As you can see in this map, he has two different areas, and as he explained, one was educated with students, 4,000, 4,000 students, and then one was educated like 200 students. And that was our independent variable. That's what changed between those two areas, the education. The dependent variable, however, on this map was the water usage data points. Now, there's a lot of different variables that we have to take into account, whether or not they change across 75224. As Omar explained, we wanted to see whether or not education possibly affected water usage, whether it increased it or decreased it. We didn't want to find out later on in our research that it was due to precipitation or irrigation. We had to see whether or not and investigate if they stayed the same with 75224, which was our research area, or if they changed. Before I go on to the next slide, I want to ask somebody, do you think that precipitation changes throughout Dallas, Texas? And if so, is it significant?
Yeah, if you talk about the whole area of the Dallas, that's different. Different area, different, receive the different precipitation.
Okay, so like around what area do you think inches?
Yeah. And then, example, I live in Arlington. If you see the Arlington, you want to figure out the different area got different precipitation. Probably the answer probably the same because the Arlington is much smaller.
Right.
And Dallas is much bigger, so you have to partition a different area to see the precipitation. Yeah.
Okay, so as you can see here, he was definitely right. Precipitation does change across an area. This is the annual precipitation for Texas for the 2012 year. And this is accumulated precipitation throughout the year. This data was received by the National Weather Service. As you can see, this is a gradient which changes across 40 inches from the lowest amount of precipitation that was received to the highest amount of precipitation that was received with the area. So 40 inches was the range. However, when you look at Dallas, Texas, you can see that there's 8 inches of change throughout this area from the minimum to the maximum. But if you look at 75224, and that was our research area, it's highlighted in yellow, you see only one shade of color, which we identified to be 31.51 to 32.23, and that's approximately 0.5 inches of change for that area. Because it's not noticeable, it's not 40 inches, between the range. We saw that precipitation didn't noticeably change for that area. There's just one shade of color, one value received, and we consider precipitation to be a constant. It's the same with temperature. Due to a geographical similarity, the Dallas region, and as you can see visually, there's one shade of color for Dallas, Texas. It ranges between 60 degrees Fahrenheit and 70 degrees Fahrenheit. We consider temperature to be a constant. And like temperature, geographical regions, you see that it's a blackland prairie. And it's the same for this strip of the Texas area. So what I did is that I outlined it, the Dallas, Texas region, and you can see that it's going to be blackland prairie from one part of Dallas, Texas to another. It's going to remain the same, especially 75224. We consider geographic region to be constant. So now we're going to look at the price of water, irrigation, and marketing. I want to ask, just to the group, does your neighbors pay a different rate of water than you? Or, what's your thought on that?
If they use more, they do.
Yes, if they use more than
If
you,
they
they
use
do.
more, they pay a higher rate at a higher level.
Okay. Well, what we found out was that the price of water for 2013, the city of Dallas, they charge 0.0017 per gallon, and that's in cents. So that's a base rate that everybody pays, in the beginning, and that's the same across Dallas, Texas, for 75224, for 75225. And because of that, because the base rate was the same throughout Dallas, Texas, from one area to another, we consider price of water to be constant. The irrigation ordinance also, it's implemented all throughout Dallas, Texas region. No one's going to receive a different irrigation ordinance than the other, and because of that, we considered irrigation to be a constant as well. Everybody knows of the Long Whisper. There's no targeted marketing for Dallas, Texas region, and because of that, we consider irrigation to be a constant. I'm sorry, I'm getting in the way, and I was just trying to better move my hands and express you the reasons why. So I'm very tactile, and we've talked about these factors. Now we're going to look at income, number of housing units, and population. What we found out was for the U.S. Census data, they receive only one value for 75224. And because of that, we found that the U.S. Census, the 2010 U.S. Census, uses 75224, that one value, to compare against other CCTAs, as it was explained to you earlier on. The population for that 75224 was 34,034, and that's the same throughout 75224. The number of households within that area was found to be 10,262, and the median income was found to be at 31,300. So that's the same throughout 75224. Because of that, we consider those factors to be constants as well. That leaves only one variable, which is our education. That's our independent variable. That's what we're going to analyze. That's what we're going to, find out whether or not it affects water usage. And Neil is going to go more in depth about this year's research.
Thank you, David.
Yep.
All right. So again, this year's research, we're going to look back at the map Omar showed us earlier, except this time we are looking at our highlighted target area. So this year we, again, remember, we found that Research Area 1 was visited less than Research Area 2 by our educators. So we decided to look at one of the CCTAs within Research Area 1, specifically 75224, and it was actually a CCTA that we'd never visited before. None of the schools had ever seen us. We decided to send our educators there, certified teachers, to teach water conservation to all the students, and then see if we can observe a noticeable behavior difference in respect to water usage. So what our teachers did was we went to the 4 schools within that CCTA, and then they taught them the lessons. Each one consisted of a 45-minute hands-on lecture, and then each student was given, little articles, giveaways to take home. And we can look at these closer in this next slide. So we actually have some examples on the table as well. We have our coloring books, our shower timers, toothbrush holders, and concentration gift cards. So these things were given away to the students so that they had something tangible to take home with them. So it wasn't just people talking at them. They had these giveaways to take home and show their family, show their friends, like, hey mom, look, toothbrush timer. And actually we got these too, and I had been waiting to get these. They were like, you get them too, and it was especially the toothbrush holder I was so excited about. And I took it home, and my sisters were like, oh, I put my toothbrush in. I was like, no, it's mine. I get away from it. So that is my toothbrush holder, and I time myself every single day. I have a good 2 minutes. Also, at the end of our lessons, each student was given the opportunity to sign these commitment cards. And what these commitment cards they are a promise that every student who signs them promises to turn off the water while they brush their teeth. This goes with the study that whenever someone signs their name to something, you're more likely to commit to the action. So in this next slide, we have a map showing the exact location of each of our schools, Carpenter, Jordan, Russell, and Henderson, and their respective school attendance zones. In these schools, we see that Carpenter taught 389 students, Jordan 566, Russell 672, Henderson 495. And in the grand total, we taught 2,122 students in the 4 areas within a 1.5 month period. If you look at these school zones, does anybody notice something a little bit off about them?
It looks like the ZCTAs, or the school zones, it's extended to other ZCTAs.
Very good observation, Omar. So, as Omar very intelligently pointed out, we see that the Russell and Carpenter school zones actually extend past the black borderline of the ZCTA boundary, right, for 75224. So in this next slide, we can see them just a little bit closer. The Carpenter school zone goes into 75232, and Russell goes into 75216. This, however, does not affect our research. Let me show you why. So in this next map, we have pretty much the same map, except this time we have our water data points plotted. And if you notice, each water data point is collected only within the school attendance zone. And this hinders the extensions of Russell and Carpenter from affecting our research. Also, with each data point, remember that it represents one of the 4,930 single-family home residences within all these areas combined, and it's tied to their water usage in gallons per month, each one. Then now Victoria will explain a little bit further what we've found in these areas.
Thank you very much. So I just want to remind you all that last year, when the research interns found these two areas that received different amounts of education, the period that we were looking at the water usage was about 15 months. This year, we wanted to see if there could be a change within only these 4 school zones in a period of 12 months, so 1 year. And we had 3 certified teachers, Mr. Shane Heffley, Dr. Alice Coe, and Ms. Christina Reeder, who went out and in 1.5 months, they taught every single student in every single grade at each of these elementary schools, which came to a total of 2,122 students. And so what we're doing this year, what the students did, is they looked at the water use for the year before the education happened, and then they looked at the water use for the year during the education happened to see if there was any kind of difference. So we're comparing this area to itself. If you look on the left, in the year before the teachers went in and taught the students, the average water use over the entire year in gallons was 7,145. After or during the year that the education occurred, from May 2012 until April of this year, the average water use in gallons was 6,558. So this is very exciting because that means that there was a reduction in water use during that 1 year period of 586 gallons. If we were to divide that by 12 and we wanted to know about how many gallons that each home saved per month, that would be a statistically significant lower usage of 49 gallons per month per home in that entire area. And 49 gallons per month might not seem like a lot of water saved, but when we take into account the entire area that we've served, Rahel will show you how big of a difference we can make.
Thank you. Here's just a visual representation of what Victoria was just saying. Each dot represents a single family residence. And actually on this map, you can't quite see it because they're so small. There is 4,930 single family homes. And if each dot saved a monthly average of 49 gallons of water, then you could see what on a grand scale, how much we could save, and you'll see that on the next slide. So what does this mean for the city of Dallas? Well, if there are 4,930 households, and each household saved an average of 586 gallons of water per year, then for this entire ZTCA, we could say that 2,891,016 gallons of water were conserved for that year. And that is just an enormous number. And you could just imagine how many gallons of water we could save around the surrounding ZTCAs, because this is just one of them. So we answered this question that yes, education can in fact significantly lower water usage. And just like David pointed out, we did exclude all the other variables, so EEI may have been a contributing factor to the success. Since we answered that question, obviously with research you could lead into all other questions. So here are some questions that future interns might have the opportunity to research. And they are, can this study be replicated in another area in the city of Dallas? If we target the same 4 schools again, will there be further change? How fast can you see change? And how could we incorporate middle school and high school presentations into this study? We'd like to thank obviously our sponsors, the City of Dallas Water Conservation Division and the City of Dallas EEI for funding this program, funding this internship for us, and allowing us to experience all the things we did. Thank you for the J. Eric Johnson Central Library. They allowed us to use their facilities to actually be able to sit down and do research on the laptops. And UNT for giving this internship again, just allowing us to be able to learn and experience graduate level research. We're so blessed.
So before we open the floor for questions, each of us would like to thank everyone personally. I'll start off. I'd like to thank the City of Dallas again for this wonderful research opportunity that I got to take part in. It's something that I know I can really take with me to college this fall. I know that with the skills and experience that I gained in graduate level research, I can really go in and soar way above my peers, kick their butts and think they're smart. It's like, no, I've done research, calm down. So that looks really good on my resume too. Then I also really want to thank for the City of Dallas for giving me the tours that we got of the water plants. There I actually found a really cool thing that I know before was that there was all these opportunities available for engineering and water management that I never knew about before. So I went in there and the first place I went to, the Elm Fork plant, our tour guide Juan was like, oh yeah, the engineers are up there, they're all our bosses. I'm just like, so that could be me. So that was really cool to find out. And another big thing was that the knowledge that the internship gave me was something that I could take with me to my home. So at home, that Armenia's family no longer waters on Sundays. All our showers are shortened, and then nobody dares to leave the water running when I'm home.
Okay, so I'd like to thank the City of Dallas EEI for this opportunity and just giving me this perspective on water usage. So by doing this research, when I saw that education can potentially have an effect on the reduction of water usage, it just occurred to me that my friend, he always turns on this faucet and he washes his hands for 30 seconds. So I kept telling him not to do that, and now that I have legitimate research to back me up, I'll be sure to lock him in a room for 30 minutes and go over the introduction and the variables, be like, hey, this is what you wanted. I mean, you had this coming, wasting 10 gallons, 45 seconds. So I'd like to thank you guys on that aspect.
I too want to thank the City of Dallas EEI. It's given me a great opportunity, and I've learned a lot, and the skills that I've learned will definitely help me out in my future endeavors. Something that I think will definitely help me out is GIS. When we first started using GIS, it's kind of hard for me, but after a while, I started using more and more, and I started to really like it and get the hang of it. And going into renewable natural resources at A&M, I can definitely use that skill. And as far as saving water, I'm definitely starting to save water too. I've started to use EEI shower timer, and it's definitely reduced my water usage dramatically, and that's something that my dad is especially happy about.
I also like to thank the City of Dallas EEI for providing us with this opportunity. I really gained a lot of knowledge and learned how really important it is for not only Dallas to conserve water, but the whole entire world. I gained a lot of skills, I was horrible at talking in front of people before, but I'm a bit more comfortable now, so I want to thank everyone for that. And yeah, so this was a really great experience.
Thank you to all our sponsors again. With me, what was really exciting was participating in graduate level research. I feel like I'm part of a small pool of students, and as you know, we're all going off to college. There will be research papers, and just gaining the the mindset and the discipline to carry out a research was something that I gained also. And again, just like we've all said, bringing home what we've learned. So it was just really interesting to see with this particular research project how each person can make a difference if you just remember all those little dots. And it just kind of gave all of us, I bet, a sense of empowerment of what we do in the future. So.
Excellent. Good job.